Good afternoon. This is Nick Mosley. UTC ID is KHY111. This is going to be coding problem set 5. Problem 2, the plain text message. So as noted here and online here, plain text message is a subclass of message and has methods to encode a string using a specified shift value. Our class will always create an encoded version of the message and will have methods for changing the encoding. There are going to be 5 implementations that we'll be using, or methods that we'll be implementing rather, according to the predefined specifications here. And so when we've got it, we are initializing this plain text object here. And so we, want to use these 5 attributes here to define the plain text message. And so it also inherits from message. And so what I didn't read this super carefully when I first initialized this, so I didn't realize that these were already predefined here in the message. We could just call those to do the less code repetition. So I just kind of commented that out to keep me honest and just to kind of remind myself of that because I mean similar logic on the ciphertext message here, but yeah, so essentially we're gonna call this from the message here, and this is what it'll be utilizing here. That self message.text is going to equal the text. We're also going to load those valid words there for the plain text message here. Going to make some changes here. So we're going to get that shift here that'll be predefined here in the testers that were given here. We are going to take that shift and then we are going to apply it to the built dictionary that we discussed in problem 1 and set that. And then we need to apply that to the message. So we're going to take a plain text message and then we are going to encode it. And then so that is the first initialization here. The other things we are just getter methods, and then we are going to change the shift. So in order, we've got to go ahead and get that shift. We need to access that shift outside of the class here. So return self.shift. Fairly straightforward, not asking us to do anything else. We just need to return this. So that's what we did. And most of this code for this is like this here. So similar deal, returning that self-encrypting dictionary. Pretty much just you read what it needs and then you return it. It needs a copy. So input that here to create a copy of it. That way no mutations happen here. The get message text encrypted, very similar here. So we just, it's not asking us to make any changes or modify anything here. So we just need to return that encrypted here. So simply return self.message underscore text underscore encrypted here. And then so what we need to do, we need to change the shift. So it changes self.shift of the plain text message and updates other attributes determined by the shift here. So new shift, shift is going to be an integer. So self.shift is going to equal whatever that shift is. That'll be, again, predefined here for us. We are going to use that encrypted dictionary. That was the first one built in problem 1 here, based on that shift. That'll be input. So we'll go through A, B, C, based on that shift amount. And then we're going to take that message and then we're going to actually apply that shift. And so, that predefined dictionary A through Z, it'll change their value there. And then we're going to use that and go through the actual message that we're given to encrypt it here. And that is problem 2. Thank you so much.